An example of an opportunity cost question using a PPF might look something like this, where here we have the trade-offs between producing a chicken finger or a hamburger for McDonald's. Right? There's a trade-off for McDonald's to do this because either they can set up machinery to sell one more hamburger, or they can use those resources, same resources, to produce and sell a chicken finger. They can't use the same resources at once to do both. Okay? So there has to be a fundamental trade-off. And so we're going to capture this opportunity cost by this PPF that you see on this graph. Now you might be asking, like, why is this graph curved? So I'm going to go back to the previous one we did with economics and biology points, where the PPF, as you see, is a straight line. And so if it's a straight line, that means that the opportunity cost is constant. It doesn't change depending on where you're at on that PPF in terms of allocating points one way or the other. Right? That's to keep it simple when I first introduced this. All right? So this is just the slope of our PPF is our opportunity cost going out in this direction. And so I can say, because the slope doesn't change, the opportunity cost doesn't change. Here, all we're doing is with this curve on this PPF, it's showing you that, well, the slope is changing, right? As we go along this curve, it's getting steeper and steeper and steeper, more and more negative. That means that the opportunity cost then is changing depending on where you're at. All right, so for this question, we want to know what is the opportunity cost of a chicken finger at point B. So here we are at point B, right? We want to know the opportunity cost of a chicken finger, so we want to go out in that direction. With one more chicken finger, how many hamburgers do we have to give up? Okay. And so we want to go something like in the direction of over one and down how many, right? How many do we have to give up in terms of hamburgers to get back down to that PPF if we increase chicken fingers by one? Okay. So the trick is when we have a question like this where we want to know opportunity cost of the X good, so opportunity cost of the chicken finger, then the opportunity cost is just equal to the slope. Okay, so in my mind, this is a relatively easy one on this graph because the slope, you can read off this, that slope equals rise over run. The rise over run here is -3 over 1, right? And so remember, what are the y-axis and the x-axis labels? So the rise is the y, right? And so this is going to be 3 hamburgers to 1 chicken finger, right? And so we can read this and say the opportunity cost of a chicken finger is 3 hamburgers. To sell one more chicken finger starting from point B, McDonald's have to give up selling 3 hamburgers. Now we could go in the opposite direction. And so now I want to ask you, what is the opportunity cost of a hamburger? So same graph. I'm also changing the point. So I could ask you also at this point A. Okay. Now the opportunity cost of a hamburger is how many chicken fingers does McDonald's need to give up to get one more hamburger? And so we're going to go up in this direction here. Our slope is -1/3. However, we want to know the opportunity cost of the hamburger. And so we have slope equals rise over run. The slope then is -1/3 at point A. And now I want you to put in the labels on those x and y axis. So when you think rise, you should think y axis, and that's going to be a hamburger. And run is going to be the x axis, and that label is going to be the chicken finger. Right? So our trade-off here is 1 hamburger to 3 chicken fingers. So if we want to know the opportunity cost of 1 hamburger, we know that that is equal to 3 chicken fingers. Okay. Right, so that's the way you can think of putting in these labels and getting that. The other way is that if you go in the y-axis direction, so up here, we want to know the opportunity cost of the hamburger. The opportunity cost will be 1 over the slope. Right? So to show you what that looks like here, our slope is actually -1/3, right? And so when we plug that in, we get 1 over -1/3, and we can simplify that. That's just going to be equal to -3, right? So 1 hamburger equals 3 chicken fingers. That's the same answer we got over here. So there's two ways for you to do it. I tend to like to do it this way. I find that students potentially make less mistakes on exams when you start writing in the labels of the y-axis and the x-axis, and you can directly think about that trade-off. So when you're doing this on exam, I suggest doing it this way to try to limit your mistakes.